The natural stone sculptures on top of Velebit Mountain bear witness to the stormy geological history of this area. For thousands of years, precipitation has been washing over and gradually eroding stones, forming fissures, sinkholes, caverns and valleys. Karst, beautiful and rough, often bare or with poor vegetation, however, at first glance, can be misleading. If we delve underground, we discover the true treasure of Karst: water. These caverns and channels are part of the karstic underground labyrinth made by water and expanded by the force of its current for centuries. Assisted by carbon dioxide, water drags the rocks eroded on the surface underground. Some of these carbonates will continue to leave sediments in underground galleries for centuries to come, at the same time creating imaginative dripstone sculptures. In Karst, long and permanent water currents on the surface are a true rarity. When water creates its own barriers and its current fashions a complex system of 16 lakes that never run dry, that is truly a miracle. Due to this natural, world-renowned phenomenon, the Plitvice Lakes have been proclaimed a national park and included in UNESCO's World Heritage List. This documentary presents the almost unknown underwater world of the Plitvice Lakes, which cannot be visited or experienced. Hidden from the curious, and therefore even more exquisite and magnificent, it refuses to reveal its many secrets. After falling on the ground as rain on Mala Capella, a mountain range situated in the heart of Dinaric Karst, water does not remain on the surface, but is immediately filtered underground where it accumulates in natural channels, which have also been formed by water over time by means of the erosion of fissure walls. A system of channels directs water into springs in the lower, marginal parts of the range. Two main springs are the cause for the 16 Plitvice lakes never running dry. The first is the Black River, named after the brown algae which completely covers its bottom, and after the conifer forest surrounding it. Although being close to its bigger sister, the White River is less fierce and has a calmer current flowing through wide sunny glades. Along the main current, there is a thick carpet of aqueous plants favoring the sandy riverbed. Scattered bubbles eke out of the sand in regular and irregular intervals. The shallow White River does not disclose the origins of the bubbles. The stronger Black River takes small particles of mud downstream, slowly deepening its bed, the walls of which reflect the river's history. The Black River current may have been less fierce in the past. During heavy rains, water would flood the lateral plains. It covered plants on the meadows as well as branches and fallen leaves from the surrounding forest with mud and sand taken from the heart of Velika Capella, resulting in the creation of peat bogs. Today, along the edges of the riverbeds, lighter layers of mud and sand are interchanged with the darker ones originating from the remains of squashed plants. As they decompose, gases are released, finding their way to the surface through the sand. Underground water is rich with eroded carbonates. The process of carbonate erosion and sedimentation is permanent and follows a cycle. If there is an obstacle on the waterway influencing its speed, water starts to leave carbonate sediments in the form of a solid, porous rock, travertine. At first, such areas give rise to smaller cascades or obstacles similar to bowls being cut apart, over which water will flow as rapids. Over the centuries, barriers and natural dams have been appearing. Below them, there are the lakes with waterfalls, where water pours from one lake to another. That's how the Croatian karstic pearl has arisen, the 16 Plitvice lakes. Due to the turbulence and a faster current, the water alongside the barriers is rich in carbon dioxide, which is consumed by plants during photosynthesis. Moss that is able to withstand the strong current takes full advantage of these barriers. The consequence of this process is sedimentation of travertine. Porous travertine structures form by air being partially squeezed into them by waterfalls, producing bubbles at the bottom of the structures. During the summer months, the amount of water flowing through the Plitvice lakes is reduced. Moss benefits from this and grows along the entire length of waterfalls, hanging like flowers over balconies. Carbonates leave sediments on the moss, which creates impressive beard-like formations. The travertine beards hanging over the waterfalls will eventually become too heavy and simply fall off. Some of them are so rough that they reach the surface beneath the waterfall and make a cavity for themselves. The barriers between the lakes grow at a different rate. The ones with a larger amount of natural armature grow faster. Higher barriers increase the water level of upstream lakes and flood those with slower growth. The flooded barriers will turn into numerous secret travertine caverns. The monumental forms at the bottom of the Plitvice lakes greatly reflect the dynamics of the travertinization process. Water currents also change, leaving some barriers empty. Here on the dry barriers, one can clearly see the strange textures of the travertine surfaces. Besides algae and moss, the roots of the trees growing on the barriers, their remains, and the trees brought by the rivers are also built into them. The variable barrier growth constantly modifies the appearances of the lakes, giving the relief of the Plitvice lakes a recognizable, unique indentation. Thick mists signal the approach of autumn. fog and the low morning sun provide the Plitvice lakes with a mystical, otherworldly atmosphere. Fallen leaves gather in lake coves. The leaves sink and darken, turning the bottoms of the coves dark and dull. The surrounding forest, then, like in a mirror, starts living its double life. The first autumn rain showers fill the lakes with fresh water. The barriers and the waterfalls hidden in rich vegetation during summer come to life. Water flows over the waterfalls in abundance, destroying the fragile, dry parts of the barriers. Beneath the waterfalls there are permanent whirls that slowly grind detached pieces of travertine, like flour in a mill. When water powders the travertine to a reasonable extent, pieces will be carried away and left as sediments downstream where the rivers cover. The mild and sylvan lake coasts turn into rocky walls of a canyon. Here the water finds its new force. On the edge of the Sastavik waterfalls, the Plitvice stream cascades down an 80-meter rock face over the great waterfall, and together with the water from the last Plitvice lake, gives birth to the Korana River. The first snow changes the landscape of the Plitvice lakes. The water turns dark. Low temperatures slow the barrier growth. The waterfalls now with a weaker current will freeze. Only the stronger ones will survive the chill. In winter, weak sunlight often filters through over the Plitvice lakes. Some dripstones will fall off and take barrier parts with them. At low temperatures, water dripping on the surrounding branches and moss freezes, creating icy balls. The reflections of light and ice create a magical atmosphere. Sprouts of butterbur, an aqueous plant that covers the barrier crowns in summer, are chained with ice. Icy balls and ribbons decorate the waterfalls in the canyon. The sun is low on the horizon, and most of the canyon as well as the upper lakes will spend the winter in the shade. The great waterfall is also frozen during winter. Only some water manages to flow through and keep the lake below alive. At the end of winter, the fringes of the lake slowly begin to melt. The ice retreats toward the calmer part of the lake, leaving strange formations on the edges. In spring, water levels rise again. The ice and snow on the lakes melt together with the snow on the slopes of Velika Kapela. Meltwater fills the underground channels and rushes into the springs of the Black and White River. The bloodstream of the Plitvice lakes returns to its full power.